Okay, I think we are recording. So you can see my screen, the web browser with the Rancher docs.
Yep.
All right, so what we wanted to do here in this session was get a practical example of deploying to Kubernetes. And so that involves setting up a cluster, setting it up in Octopus, dealing with some of the authorization credentials options that we have. And once we get that far, we'll then try and deploy a sample application and we'll get it running. So the first thing to understand with Kubernetes is the concept of the control plane, like the master and the workers. And so this comes up, or this is exposed in the managed Kubernetes services. And so we're going to use Amazon's one for this one. That's called EKS, and they're reasonably popular. But from the tickets we get, it seems that EKS is one of the more popular ones that people are using. So it seemed like a good target for this demo. So yeah, basically you don't have to go into too much detail about what's inside these boxes. Just understand that there is this thing called a master, and there are these things called workers. The workers are just VMs typically. In this case, they'll be EC2s, and it's the workers where we typically host the applications we're deploying. The master is usually something that's managed by the cloud provider, and you don't get a whole lot of access to it. So that's true for both Amazon and Azure. They create and manage this control plane, and you don't get a lot of insight into that, the hardware or the configuration that goes into there. So the first thing that you'll want to do is actually create the cluster. And so there's a million ways of doing this. You can do it through obviously the Amazon interface. If we went here, there'll be a create cluster option here. For Amazon, there is also the command line tool, which is called EKSCTL. And so this is a command line tool that offers an opinionated and simplified workflow over the top of CloudFormation. It used to be that setting up a EKS cluster from a console was a whole lot of different CloudFormation. It was quite a pain, but EKSCTL has made it a lot easier. And to make it easier, again, we actually have a community step template that does most of the work for you. So if we have a look in here, so you'll find this community step template. This is one that Michael Richardson created. What it's going to do, and we won't actually run it because it takes minutes to stand a cluster up, and I've already done this myself. But yeah, basically what you're going to do is fill out your. I just realized I needed to create an account. Yeah, you'll just fill in the details, and what this step will do is create the cluster using EKSCTL, and then actually create the target, the Kubernetes target in Octopus. So it kind of handles it all for you. So this is an easy way, and actually you guys have access to this as well. The account that I'm using here is this one here, Cloud Deployer. This one here. So if you were to open that up, you would get the details of that account, and that's the account that we tend to use for creating test infrastructure. And by test infrastructure, I mean infrastructure in the US East 1 or East 2 regions. They tend to hold our just like ephemeral testing bits and pieces that people spin up randomly. The config here is just a YAML file. I'll actually post an example of this, but the docs here have an example as well that you can copy and paste from if you need to. Deployment name is my target. the roles that will be assigned to the target. Obviously, the default worker pool as well. And so that's it. If you take the values that I've put in here, and actually, I think I do tell a lie. These two do have to match. So that name has to match that one, and that region has to match that one. But if you take these values and run it, what's going to happen is you'll get a cluster, an EKS cluster in the US East 1 region, and you'll get your Kubernetes target created as well. So I'll save it but won't run it because we've already done that, and the result of me creating one earlier was this cluster here. So what I'll do now is actually manually set that up in Octopus as a target, and so this will give you a good idea of the kind of settings that need to go into a target to get it to work. So there's actually 2 bits of information we need: the name of the cluster and this API server endpoint here. So I'll take that endpoint and create a cluster. So you do get a choice of authentication. Now, technically, username, password, token, and client work with any Kubernetes cluster, as long as you've set it up correctly. But the cloud providers, we do also offer the ability to tie into their specialized authentication mechanisms. And again, we'll just reuse that AWS account that I created before. That endpoint that I pasted in just came from here, and this is the name of the cluster, and that needs to go there. So there is these endpoints have self-signed certificates, which you would either have to install into Octopus and select here, but just for convenience, we'll skip that and just allow it to accept the self-signed. And that should be it. So let's check the health, make sure that it's all good. And so what's happening, or what will happen in the background, is that this target will create a Kubernetes config file that links into the AWS authentication executables. Those executables are actually already available in hosted, so you get that kind of for free. But if this was your own Octopus instance, you'd have to download the executables and install them yourself. And we'll see that later. So what we can see here, that's the URL. I've left the namespace as default. We'll have a look at namespaces a bit later on, and it's named the cluster as well. And so the health check is passed, and we can see that it's managed to get the version of Kubernetes from the server. And so that means our auth is passed and all our connections are valid. And so these version numbers are interesting. There's something to pay attention to. Kubernetes, I think, has minor releases every 6 months or so. Cloud providers tend to lag behind though. So by default, this cluster was created with 1.15. It's only going to let me go up to 1.16. But actually, I think we're up to 1.18 is the latest release of the upstream. Yeah. So that's just something to be aware of. Some features, we do sometimes add features to the product that are version specific. And it's just, you need to be aware that sometimes the cloud providers don't actually let you upgrade to the latest version right now. So there may be people trying to use a feature that we've exposed because it's been released in the latest version of Kubernetes, but they just can't get access to it until the cloud provider catches up. So that's it. We have a target. So we're now good to start looking at what we can do with it. So what I'll do here So there's going to be a lot of kind of diagnostics and querying that you'll need to do of the cluster, just to make sure that the things you put in are running as you expect, and maybe to get some of the details of perhaps the URLs for any load balancers that you want to hit. So what we'll do as an example here is just show the nodes that are in that cluster. And so we do have a step that will make this easy for people. That's another community step. That's this inspect resources one. And so this step here is a wrapper around the kubectl tool, but it does a few nice little shortcuts for you. And so some of the shortcuts are that it's just going to give you drop-down lists for resources, so you don't need to know a lot of these off the top of your head. And you can create artifacts of the results. So what I'm going to do here is get the nodes and save that result into a text file. And this will show us, this will make sure that all our credentials are correct and that we can get access to the cluster to actually query it. So you can see the other thing it'll do is actually show you the commands that it's running. And if you wanted to, you could copy and paste those to a terminal if you needed to. So it's also a good example for that. And so what we've said is get node. We see the two nodes, and those two represent these two here. So these are nodes, and these are the details of the nodes in our cluster. So one thing to also be aware of is that EKS has a whole bunch of different ways of creating nodes. And so if you came here and tried to look at the nodes, you wouldn't see anything. And this is a bit confusing. It's because there's AWS has a bunch of different concepts of how it manages nodes. And the EKS CTL tool doesn't create these sorts of nodes. You can actually see the VM instances that represent the nodes though. So here I'm in the EC2 list, and this one here, and this one here. These are the two actual VMs that match these two nodes here. So yeah, from a support point of view, there's sometimes more than one place to dig up information if you need to get it. So that's something to be aware of as well. So what we'll do now is create a service account. And so a service account is a type of account in Kubernetes that's designed to have machines connect to it. So there'd be like a user account, which is expected to map to a real person. But when Octopus is talking to a cluster, it's typically going to be using either the specialized credentials of a cloud or a service account. And to do that, we'll create another runbook. What we're going to do is deploy some raw YAML. And so this step here is a way of basically just copying and pasting the YAML resources, which is typically how Kubernetes represents the things you create in a cluster. You can actually use JSON as well, but YAML is definitely the more popular, and certainly in all the documentation, it tends to default to YAML as an example. And so what we're doing here is creating 3 different resources in Kubernetes. The first one is a service account. So this is just the name of an account. The next one is a role. And so this grants permissions to various other resources within Kubernetes. So Kubernetes has role-based access control. So this role here is quite permissive in that it grants access to everything. API groups just kind of reference these values here. Resources tend to reference the name of the resources, and the verbs of the action. So you can get, describe, delete, things like that. And obviously asterisk here just means we get access to everything in this case. And so the role is then associated with an account through a role binding. And so basically we're just saying that the service account called Octopus Deployer will be bound to the role called Octopus Deployer role, which is this. So this one here is created, this one here is created, and then they're bound together with this. And so at this point, I'm running this deployment through basically the admin user. That AWS account that we had before is an admin, and so it has all access, and so it can do whatever we want. And the idea of having a service account is that you'll have a more restricted account in this case. And actually what I probably should have shown there was that we never specified any namespaces in that. And so all the namespaces for these resources will default to the namespace called default. And so what that means is we're creating an account in the default namespace, and it has access to everything within that default namespace, but can't actually, well, couldn't access anything outside of that namespace. So if you had a namespace, my namespace, or Doug's namespace or whatever, the account we're creating here doesn't have access to that. And so that's a nice way of kind of creating security boundaries within Octopus. Take a second to go through. I might just leave that. Because the other thing we need to do while that's running is actually get the secret, get the token, sorry, that serves as the password for that service account we just created. And so what happens here is that every time you create a service account in the background, Kubernetes creates a second resource called a secret. And in that secret, we have a token, and that token serves as our as the password that we use to get into that account. And again, as you can see, there's just a whole lot of this: create and inspect, create and inspect, create and inspect. It's just a pattern that we go over and over. So in this case, we want a secret. We want to actually get the YAML representation of this secret, and this is going to give us all the data in that secret resource, and that data is going to obviously include our the token. Whether you would actually do this in a runbook or not, I mean, probably not, because that's going to put a secret value in the logs somewhere. But we'll do it here anyway, just because it's the most convenient way to show this off. Let's see how it went. Service account, there we go. So, yep, we just go into the logs and we can see that those 3 resources have now been created. So let's go back and get our token. So the name of the token will be the name of the service account dash token, I think, actually. Let's have a look if I was right there. Where are we? Yes, type. Where's the name? Yeah, Octopus Deployer dash token. Anything that Kubernetes itself creates automatically tends to have a randomly generated string appended to the end. You'll see this with the pods that we create later. That can make it a little bit difficult if you're telling people how to, or which resources they need to look at if they're trying to debug something. You can't often give them the exact name of the resource they're going to get. You can only kind of say that the name of the resource starts with this, but will end in something random. So that's something to be aware of as well. So this one here, token, this is the password essentially, of that service account. And that's base 64 encoded. So we'll actually need to decode that to get the password. I want decoder, paste that in there, decode. So this one here is the actual password. So that becomes a token account. This name doesn't have to match anything. Actually, I'm just call it large just to prove that. And I'll just paste the token in there. So to show that that works, we'll actually create a new cluster, but this time we'll use token auth. Let's call this, don't want to deploy to it, we'll just keep it here, token. And so you'll notice I'm no longer specifying a EKS account or EKS cluster name here. That option is not valid anymore. So what we do need though is still that URL of the API endpoint. And again, we'll just skip the auth. Just leave that go. But so we expect that this health check to pass as well. But we've now, okay, there we go. But we've now removed any AWS specific authentication process from this. And so that is potentially a good support technique as well to isolate any specific cloud specific authentication problems. All right, so I will just quickly show another little debugging technique that you can do. So this variable here, well, the history of this is we used to display the generated Kubernetes config as a debugging technique in the verbose logs. The problem is kubectl, it turns out, had a bug and that was leaking passwords into the logs. So we still retain the ability to show this config data, but you do have to set this variable here to true to make that happen. So if I now run one of my other queries, what we'll see in the logs is a copy of the kubectl config that Octopus is actually using to connect to the cluster. So that's this here, starting from this API version down to here. And so this content here is exactly what you would place in the file config under the .kube directory of your user's home. And that's, these are interchangeable. And if you have that file locally, and you have logged in to AWS with AWS configure, so this means you have the AWS CLI tools installed, and then you copy that access key and secret key into this configure, into the prompts that it'll bring up. We can then run these same commands locally. So kubectl get nodes. So these are the same nodes you saw before. And so the important thing about this login or this configuration file is that the login is all being handled by this executable here. So this is kind of acting as a mediator between the credentials you have set up through a call to something like AWS config and the Kubernetes cluster. And just show that I have. So I've installed this command through Chocolatey, and so it's come up on the path as being here. If I didn't have this file, the login procedure would not work. And actually, we can probably demonstrate that. Let's see if I can rename this. Okay, so I've renamed the file. Basically, we now no longer have that on the system, and my kubectl won't work. And you'll see a similar kind of error message through Octopus itself if that file doesn't exist. So that's something to be aware of. Yep, all you need to do is download it, put it on the path, and you're good again. Okay, so it's probably now time we can jump in and actually try and deploy something. The example that we'll deploy is random quotes. This is just like a place sample application we use for some of the documentation. And this is where it has been made publicly available through Docker Hub. And the source code for this comes from GitHub. So this is the Docker file that we use to build up the application. I won't delve into this particularly. The only thing worth noting out of this is the expose command. And what that says is that this Docker image exposes a web app on port 80. And that's not as common as you might think. 8080 or any other port is actually more common than 80. So you can't assume that everything will be 80. It just happens to be in this case. So before we can deploy a Kubernetes application, we need to set up a Docker feed. And the default URL that it gives you is the one for Docker Hub, so that's convenient for us. There are other services that provide Docker feeds. All the cloud providers have their own setup, and the URLs will have to change to reflect that. But we tend to just use Docker feed for our, Docker Hub for our own tests. So I'll just save that and let's make sure. So the name of a image is this. So this is how we reference images, and we should be able to search for that and find it. Okay. So this means our feed is connected, and that's it knows how to get this particular image. So let's create a Kubernetes project. I'll just call this. So the step that we'll use is this one, deploy Kubernetes containers. And so this is a opinionated step. The idea here is that it's very user interface heavy. You're expected to basically populate a form, and then Octopus will take those values, build up that YAML that we've seen before, and then deploy that to the cluster. So the benefit of this one is that you don't really need to know the structure of the YAML. You do have to have a relatively good idea of what you're trying to deploy, but you know, the specific names of anything is not something that you're expected to remember. And so this step creates what's called a Kubernetes deployment resource. And a deployment resource is a structure that manages pods, and pods in turn manage containers. And so our whole goal here is to get this container running in Kubernetes. But there's a couple of different levels that we go through before we get to that point. So we'll call this random quotes. The defaults here are all fine. I may leave deployment strategy for later. That might be something we can get back to if we have time. The thing we're actually really interested in here is the containers. What we're actually defining here is a pod, and the pod contains one or more containers. So we'll call this also random quotes. And we're going to get the image from Docker Hub, and this is where that feed comes in. If you didn't have the package feed, you'd have an error here saying that you can't, that you need to have a feed basically before you start. So we'll chuck in that package ID. Yep, there we go. So we found it. The other thing we need to do is now expose the ports that we expect traffic to come in on to this container. And that's where that port, this is where this port becomes important, the port that the container exposes. So we'll call this port a web port, and it's port 80. Protocol defaults to TCP if you don't specify anything there. And so we'll now get the pod and kind of an overview of what that is. So that's all we need to do to actually get a deployment in. So I'll just save that and we'll run it and see what happens. I should point out here, these versions, these are tags. So if we go back here, we look at tags. That version there pulled off or consumed this this version here. These traditionally used to have to be semver. With recent versions of Octopus, though, it's become a little bit more lax. They don't have to be strictly semver anymore. But certainly for all our examples, we've stuck to semver for this. So what Octopus has done in the background is created some YAML from those inputs to represent the deployment YAML that Kubernetes expects. It's waited for the deployment to roll out, so there might be some containers that maybe take a few seconds or minutes before they consider themselves healthy. In this case, it's fairly quick though. And the deployment has been good. And if we look into verbose logs, we can actually again see the YAML that's created. So all these labels are ways that Octopus identifies deployments. This is useful for us if we need to match resources because we know the project and the action and the deployment, even down to the step. We know how this particular deployment or resource came about. And again, those labels get applied to the pods that this deployment creates. And this is the container image that we specified. So that's random quotes in the tag of 104, and that's the port that we exposed. And so we're done now. So we've deployed this application and it's in the cluster. The only catch is it's not accessible. The pods that we've created from this deployment, we should actually have a look at that. The pods are basically isolated. They're sitting there, they're running, but nothing can get into them. And we certainly can't get into them from a web browser. So if I have a look at their pods, so I'm just going to get the pods. And what we'll see is, because the replica count was 1, which was the default, we didn't change that, that deployment will have created one pod. And that pod will be random quotes, and again, random stuff on the end because it's something that Kubernetes itself created, and that's how it generates unique names, is just random strings on the end. But we're good. It's ready, it's running. Yeah, everything looks good at this point. So what we need to do now is actually make this pod accessible. And because it's a web app, we expect people, end users, to be hitting it with a browser. So to make anything accessible, we need what's called a service. And a service is it's a representation of networking configuration. So by deploying a service resource, we're instructing Kubernetes to configure its internal networking in such a way as to allow access to that pod, or the many pods if you have more than one, based on a known host name. And the host name in this case matches the name of the service. What we do want to do though is make this service available to people from outside the cluster. So if we did cluster IP, the pods would be accessible internally. So you can imagine if you had a database perhaps that multiple pods connected to, but you didn't want to expose that to the general public. You just have a cluster IP, and that keeps it all our communications internal to the cluster. Node port is good for debugging in that it'll give you a kind of a random port over the 30,000 range that you can use to access the service, but it's not something you'd typically use for production because port numbers are hard and firewalls tend to block them. So the other option here is load balancer. And what this will do is create a AWS load balancer, in this case, an Elastic load balancer. And that load balancer will be public. It'll have a public host name, and it will have all the networking it requires to get into the cluster and then into the pod. So that's what we'll create here. And what we'll need to do is hook up some of the ports. And so what we're doing here is taking those, what we're saying is we want to expose the external port that I'll hit when I'm talking to it through my web browser is port 80. And that in turn reaches into the pods on port 80. And if you remember, that was the port that we exposed. That was this port here. Node port is not important. We won't be using that. So we can just leave it at that. Actually, another good little debugging trick is the YAML representations of the things that are being created exposed through this edit the resource YAML section. So if I click this, I can get a kind of an export of what this section will create, and I can actually edit these as well if I wanted to. So if I call that web 2, for example, what we should see is web 2. So that's been reflected down here in the service ports. That's also true for this deployment. That's the YAML that we expect this resource to create. So save that and rerun it. So if you remember before, we saw log messages saying that a deployment was created here. We'll also now see one that a service is created. And so there's our service, and that's the new bit of functionality that we just added. So now the question is, great, I have a service, but what do I actually type into my web browser to access that? And again, we'll jump back here and we'll just query the cluster to get the details of the service. So you can see that there's a lot of this create and query process as you're setting up new infrastructure or new Kubernetes deployments. But the benefit of doing all this as a runbook is that once I'm done with this cluster, I've left the next person a nice little collection of scripts that I know were at least useful for me to work with the cluster. That's probably going to be useful for them as well. So we'll go service. The get verb here will get me what I want. So that's all we need. on that one. Right, so this is the service, called service of type load balancer. And this is the public hostname that was created because EKS knows how to create Amazon load balancer. And Kubernetes is smart enough to kind of link these two up, so I can query these external load balancer resources from within Kubernetes. We could actually probably see that if I go down here. ABA, was that mine? Yeah, ABA 689. So that's this load balancer here that's been created for me. And if we had a look at the host name, DNS name, so that's what that value there has been returned to us through Kubernetes, through here. So if I type that into my browser, and there's our sample application. And so we have now deployed and exposed the application in Kubernetes. And that is, I mean, obviously you can go a lot deeper than that, but this is enough to get you up and running and kind of testing and replicating with Kubernetes. But what we will do, because we've got a couple of minutes, is jump in and install an application through Helm. And we'll install the Kubernetes dashboard, and that will give us something else we can inspect the cluster with. So Helm is like a package manager for Kubernetes. It provides the configuration that Kubernetes needs to install typically more complex installations. So you'll find things like there might be a WordPress Helm chart or a MySQL Helm chart, and they will typically expose a lot of variables that you can tweak to install your application, and they'll potentially also combine a bunch of different containers to create a complex stack. Whereas here we've kind of done this as a individual deployment of a container only. Helm is a way of mixing it up a bit and giving you those complex combinations of tools that work together to create an end result. So what we'll need for Helm is another feed. This is a type of Helm feed. The actual feed that we want, and you'll just have to take my word for it that this works. If you actually Google Kubernetes, I could probably show you actually Kubernetes dashboard Helm. It's this URL here. So they've just told us where to get it from. So that's what we've put in. Feed names, let's call this dashboard. And that's the package that we want. So that's the Helm chart that we're going to try and install. So if we go back in a project, dashboard. So that's what we want. Let's just call this Kubernetes dashboard. You need to have a unique name. So this is like, I guess you can kind of think of this as being the name that shows up in the add remove software list in Windows, for example. That's just how we identify the installation. So we can update it later on if we need to. Helm client versions. Version 2 was the one that made Helm popular, but it had some security issues. Just the way it was constructed lended itself to a not very good security standpoint. So they rewrote it with version 3, and the two executables are not typically compatible. The good thing about version 3 though is version 2 used to have the requirement of a service installed on Kubernetes first. So the Helm 2 client would talk to the service in Kubernetes. The service was called Tiller, and then Tiller would do most of the work. Version 3 doesn't have any server-side components. All the processing is done locally, and the processed result is sent up to Kubernetes. So the catch here is actually that our worker needs to have the correct version of Helm installed. Actually, don't know off the top of my head if dynamic workers have Helm 3. I'll soon find out. But there's a way around it if they don't. I guess we'll see what happens. So Helm charts are just basically archives of text files, really. Mostly they're just text files of those YAML resources that we've seen, although Helm does have its own unique files for, say, the variables. But as you can see, they're quite small. They're just bundles of text files. So I'm not actually sure what this is doing. I expect it to be a little bit faster than that. Oh, okay, there we go. Okay. This probably won't work because, as it turns out, yeah, there we go. The Helm tool distributed with the dynamic workers in the cloud is v2. Our cluster hasn't been set up with that server-side component that v2 needs called Tiller. We've assumed v3, but actually this is probably a good opportunity to show how we can work around that. So what I've just done in the background is downloaded the Helm executable, and that just came from the GitHub releases page. So this page here just has links to binary downloads. And so I've downloaded that here. So what I'm going to do, I'm just going to rename this file so it's something we can upload to Octopus easily. Yeah, turns out I've already got that somewhere. Okay, so if I go back to here, library, upload. Downloads, let's go Helm. Okay. So basically I'm just uploading that zip file. If we go back to the dashboard, process. All right, so the tool that's used is something you can also define in the step. If I select custom package tool, go Helm. So that's the zip file that I uploaded, and I just need to get the directory structure. So I think what it expects here is that. So that'll tell it where in this particular package that executable comes from. Let's try that again. Okay, so you can see now, instead of using the tool that came with the dynamic worker, I've actually specified which particular tool I expect to be used. And I know that's version 3 because I I supplied it. Right, and there we go. So our dashboard has now installed. You can see here that they've actually created a cluster IP for you, but that doesn't give us access. That doesn't give us the access we need. So what I'm going to do is get the services so we can see that. So I get the services. The other thing we may need to watch out for is sometimes Helm creates things in its own namespaces. So the default namespace of default may not be what we want. Okay, but it is in this case. So here we can see so this is an example of kind of a complex bundling of different things being put together in a Helm chart and it's served as one installable. So what the Helm chart has actually done is install both the container that runs the dashboard and also a service here that exposes it, but only exposes it internally. There are ways to proxy into the cluster to get access to that, but what we will do, assuming we have enough time to show this off, is create a load balancer for ourselves. That'll just give us access. So what I need to do is see how that service is selecting the pods so I can replicate that information for myself. And so all I'll do is change the verb to describe. That'll give me more information about the services. And again, this is a handy thing to know. Like get is like a simple directory listing, whereas describe is a kind of a detailed report on each of the objects that you're getting back. So here we can see right, this is the one we want, the name Kubernetes dashboard, and what I'm looking for is the selector, which will be this one here. So that might just be enough. What this is saying is this service is selecting any pods with a key of blah 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 component and a value of dashboard. And it matches on a couple of other ones, but I think we can probably just take this first one and run with that. So let's go ahead and create a runbook for 2 minutes. Hopefully we're gonna sneak this one in. Okay, it's the load balancer. This is actually a good chance to show off another step. So you're not actually you're not actually limited to creating the resources in that big opinionated step. The individual components that you can create are also pulled out into their own individual steps. So I'm going to create a service. I want it to be a load balancer, and I want it to select pods where the name of the label is that and the value is that. I do need to expose some ports. Let's call this web. I'll expose port 80. I have a feeling they use 8080 internally though. Let's see how we go. Service name. My dashboard. Cool. Right on the line. We'll see how we go. Okay, service was created. So I do expect a load balancer resource to be created, which is this one. Let's grab the DNS name, throw that in here. If I've guessed correctly, which it doesn't look like I have, that would have been exposed. So what's happened here is I probably haven't got the correct ports set up, but I think we've done our hour, so we'll have to leave it there. So I know I've run right up to the limit. Is there any questions you guys have, or anything that any further information I can put in the channel later on if it's helpful?
No, that's been great. Thanks, Matt.
Yeah, thank you very much. Very extensive.
Thank you. Well, hopefully that's I gave you some tips for dealing with some support tickets. And
Absolutely.
yeah, and I'll catch you in the support chat, which I think is starting right now.
Yep.
All right. Thank
Thanks
you.
again.
See ya.
Bye.